Welcome to episode 503 of AI Brief. We have an absolutely packed deep dive for you today.
We really do. There's just so much ground to cover.
So just to give you a quick preview, today we are looking at Google DeepMind cracking open unsolved math problems, an AI uncovering hidden planets in our galaxy, and then we will do a rapid-fire look at the rest of today's AI news.
Plus, we will break down the top new AI tools to boost your productivity.
For sure. And the overarching theme we're exploring today is that we are literally watching AI graduate. I mean, it is moving from a simple chatbot on your screen into a massive autonomous engine for scientific discovery.
It is stepping out into real-world physical exploration. The ceiling of what we can discover as a species is suddenly being pushed upward.
It really is.
And, well, more importantly, the actual methods we use to make those discoveries are changing overnight.
Okay, well, let's unpack this right away. Our first major update comes from Google DeepMind.
Oh, this one is fascinating.
It is. So they just published a paper on their new AI Co-Mathematician. And, to kind of set the scene here, this system was built on Gemini 3.1, but it was tested on Epoch AI's Frontier Math Tier 4 benchmark.
Which, just for some context for the listener, is definitely not your average high school calculus test.
Not at all.
I mean, the Frontier Math benchmark is basically a gauntlet of research-level problems. These are equations that often take human PhDs, well, weeks or even months to solve.
And historically, these specific problems have just completely stumped artificial intelligence.
Because they require actual leaps of logic. You can't just retrieve facts from a database to solve them.
Well, the raw score for Gemini 3.1 Pro on this benchmark was just 19%.
Ouch.
But DeepMind's new system scored 48%.
Wow. They more than doubled the performance.
They did. And here is where it gets really interesting. They didn't do it by just throwing more raw computing power at the problem.
That's usually the go-to move, but not this time.
No. Instead, they changed the fundamental architecture of how the AI approaches the problem. They basically modeled this new tool after agentic coding environments.
Oh, like Claude Code?
Similar to that, yes. They brought team-based workflows directly into mathematical research.
I love that.
So think of it like a corporate workplace. You have a coordinator agent acting as the ultimate project manager. You hand this project manager a massive mathematical task.
And instead of panicking and trying to solve it in one massive computational gulp,
It breaks the research down.
it delegates.
Yes. It creates parallel work streams. So it assigns one subagent to write Python code to test theory. It sends another subagent to scrape through historical literature to find precedents, and it tasks a third subagent with attempting the actual proofs.
And they are all working in parallel, reporting back to the coordinator.
It is basically acting like a lead investigator assigning homework to junior researchers.
Which is wild. But, what is truly fascinating here is the mechanism of how those subagents interact, specifically when they fail.
Oh, the review cycles.
Yes. The system has built-in review cycles where the agents actually check each other's work. This brings us back to that Oxford mathematician, Mark Lackenby.
Right. He was working on that famously unsolved problem.
From the Karufka notebook, yes. So he used this new AI co-mathematician, and the system did not hand him a neat, perfectly packaged solution.
Wait, it failed.
It did. In fact, the AI's internal reviewers rejected a particular output generated by one of its own subagents because the final proof was mathematically flawed.
The system itself threw it out.
It said, this is wrong, toss it. But Lackenby decided to look at the discarded work anyway.
Digging through the AI's trash.
Pretty much.
Yeah.
And he spotted a brilliant, highly unconventional proof strategy buried inside that flawed attempt.
That is incredible.
He took that raw, weird strategy, refined it with his human intuition, and actually resolved the open problem.
So it proves a critical point about where we are with AI right now. It functions as a massive accelerator for top human minds. It is not replacing the mathematician.
No, it is acting as a tireless brainstorming partner, one that can generate thousands of bizarre angles of attack, even if some of those angles are imperfect.
But hold on, if the AI's internal reviewer rejected the output, doesn't that mean the AI is still a bit too rigid? I mean, it threw away the golden ticket.
That is a really good observation. The AI recognized the logical flaw, but it lacked the human intuition to see the potential in the strategy.
So it can brute force creativity by generating endless paths, but it still takes a human expert to recognize a diamond in the rough.
Precisely.
Well, what does this all mean? It means AI is learning to explore the abstract universe of math, But what about the actual physical universe? Let's move from theoretical numbers to deep space.
This is the perfect transition. We have an astonishing update from the University of Warwick,
Astronomers there have successfully confirmed more than 100 new exoplanets using an AI system called Raven.
which is a massive leap forward.
Raven scanned 4 years of data from NASA's TESS mission. For you listening, that data covers an unfathomable 2.2 million stars.
That is an overwhelming amount of information to process.
And Raven didn't just confirm over 100 planets, it also flagged more than 2,000 additional potential candidates that are pending confirmation.
To really understand why this matters, we have to look at how we normally hunt for planets. Usually, astronomers use the transit method,
Right, staring at a star and waiting for a microscopic dip in brightness.
which implies a planet just crossed in front of it,
Yeah.
but doing that manually for 2.2 million stars is impossible.
Previously, astronomers had to use piecemeal tools or, manual human processes for different stages of this hunt. But Raven handles the detection, the vetting, and the confirmation all in one single pass.
And it was trained on simulated planets as well as false alarm signals. That is the key mechanism here.
Learning to filter out the noise.
Yes, it learned how to relentlessly filter out the instrumental glitches or binary star systems mimicking a transit and just isolate the real planetary finds.
The discoveries it made are genuinely mind-bending. I mean, Raven found 31 exoplanets that had never been spotted before. It found bizarre worlds orbiting their host stars in under a single day.
Those short orbits are fascinating.
But here's the part that makes me want to push back. It found hundreds of exoplanets in what astronomers call the Neptunian Desert.
The Neptunian Desert, yes.
Oh, wait, the Neptunian Desert is a region of space so punishingly close to a host star that, theoretically, a Neptune-sized gas planet shouldn't even exist there.
The intense heat and radiation should literally boil and strip away the planet's atmosphere entirely.
So how can we trust Raven isn't just hallucinating data?
That is the exact question astronomers asked. But remember how Raven handles vetting and confirmation simultaneously?
Right.
It analyzes the light curves with a level of statistical rigor that human eyes just can't match. It proved with high confidence that these planets are thriving there.
Defying our current models of planetary physics.
And if we connect this to the bigger picture of space exploration, the magnitude of this achievement becomes very clear. Throughout human history, we've only managed to confirm a few thousand exoplanets out of the trillions that exist.
What Raven proves is that we don't necessarily have to wait for the next generation of multi-billion-dollar space hardware to make groundbreaking discoveries.
The data from NASA's TESS mission already existed. It was just sitting on servers.
Gathering digital dust.
Exactly. Raven was able to measure how common different planet types are at 10 times the precision of previous systems, purely by applying smarter software to old data.
We are unlocking the secrets of the universe simply because we finally have the AI capable of understanding what it is looking at.
It is a profound shift from relying entirely on hardware collection to relying on software synthesis.
Which brings us perfectly to the rest of today's news. We've just seen how AI is building new paradigms in math and discovering planets. But with the sheer volume of AI advancements happening outside of the science realm today, we need to look at how that massive scale translates to infrastructure right here on Earth. So, I will hand the reins to you to break down the rest of the news landscape.
I've got it. Let's adopt a slightly slower, more measured rhythm here to digest all this, starting with the platform layer. Prime Intellect's lab is officially out of beta.
Oh, that is a major democratization of AI development.
It really is. It bundles everything you need to run a model and benchmark its performance. Anyone can now build, evaluate, and deploy custom frontier models and self-improving agents trained entirely on their own private data.
That is a big deal for developers.
Meanwhile, Baidu has released ERNIE 5.1, which just hit number 4 on the overall search leaderboard. But the shocking detail isn't its rank, it is the cost.
The training cost, right?
Baidu claims it costs just 6% as much to train as its rival models.
6%. That signals a fierce new battle. The moat is no longer just about who has $1 billion for raw compute. It is becoming a war over algorithmic training efficiency.
And speaking of efficiency, OpenRouter just launched Pareto Code. This is a highly practical routing layer for developers.
I loved this concept when I saw it.
You set your minimum acceptable quality bar for a coding output, And Pareto code automatically routes your prompt to the absolute cheapest coding AI that meets your standard.
The prices adjust dynamically as newer models improve. It essentially functions like a real-time stock market for AI logic. You are always getting the best price for the specific IQ level you need.
Okay, so that is the software side.
Yep.
But the virtual and physical infrastructure space is where things are getting wild. Reactor has launched a platform that lets anyone explore AI-generated worlds that render in real time straight from a web browser.
So no lag.
Reactor is positioning itself as a core infrastructure layer here. They are betting that delivering these dynamic environments without lag is going to be the main bottleneck for the future of virtual AI generation.
But AI isn't staying virtual.
No, it is not. In the physical realm, Apple is reportedly in the final design steps before mass production on upgraded, camera-equipped AirPods.
Wait, cameras on AirPods?
This is a massive leap for physical AI interaction. These AirPods will pair the outward-facing cameras with a smarter, multimodal Siri.
So you could literally look at the ingredients in your fridge, and Siri processes the visual data to generate a recipe in your ear.
Or you could pull detailed product reviews while staring at an item on a store shelf. Or grab calendar info simply by glancing at a concert poster on the street.
But all of this real-time visual processing requires an immense amount of power.
Which perfectly explains our next update. SoftBank Group's telecom arm has officially launched a large-scale battery business. They are building massive cells and industrial storage systems explicitly to meet the skyrocketing power demands of AI data centers.
That makes perfect sense.
And finally, looking at the global impact, Google's Isomorphic Labs is reportedly raising over $2 billion to expand its drug design engine, which they claim is outperforming AlphaFold 3 on specific drug discovery tasks.
A huge leap for medicine.
And on the geopolitical front, Greece is making a landmark move. They are proposing enshrining AI protections directly into the Greek constitution, legally requiring the technology to serve individual freedom and safeguard democracy.
Synthesizing all of that, a very clear pattern emerges when you look at Apple's camera AirPods alongside SoftBank's massive battery push. For you, the listener, it is easy to think of AI purely as software, just a tab open in your browser.
But the biggest developments happening today are actually a frantic race to build physical infrastructure.
Yes. The hardware required to bring AI out of the cloud and into the real physical world is immense. Apple is putting cameras on your face to feed visual data back to the AI, and SoftBank is building giant industrial batteries just to keep those processing servers from browning out the grid. The software is ready. The physical world is desperately trying to catch up.
Which naturally leads us to ask, well, how do you keep up?
Let's bring all this massive scale down to the screen right in front of you. Let's walk through today's trending AI tools and explain exactly how you can apply them to your daily workflow. First up is Guide.
This is a lifesaver for managers.
If you are constantly having to onboard new employees or explain software processes to your team, Guide is incredible. It uses AI to monitor your clicks and instantly creates step-by-step video documentation.
It completely removes the friction of manually recording and editing tutorial videos.
Next is Adject, which is a game changer for marketing and e-commerce. You can use Adject to instantly generate highly realistic product visuals.
And the mechanism here is fascinating. Think about what goes into a photo shoot: lighting, angles, rendering. Adject bypasses the physics of rendering entirely.
It uses diffusion models to hallucinate perfect lighting and environments around a flat 2D product image in seconds.
You're generating the math of light, not shooting a product.
Then we have Sadie, which provides real-time voice translations specifically tailored for the workplace, breaking down language barriers during live video meetings.
Perfect for remote teams.
And for the creatives listening, Upsynth offers a single, seamless editor to restore and drastically modify photos using AI.
It consolidates what used to take 4 different complex software programs into one single interface.
Moving to digital marketers, Cupera is designed to fully automate your entire search engine optimization workflow. It doesn't just suggest keywords, it analyzes search trends and updates your website content autonomously.
We also have Codex in Chrome. This is an incredibly powerful extension from OpenAI that lets you run agentic tasks directly inside your web browser.
Here is why that matters. Instead of switching tabs, copying data, and pasting it into a chat window, the AI agent works right over the web page you are actively viewing. It reads the code of the page and executes tasks natively.
It basically takes over the mouse for you.
We mentioned Baidu's Ernie 5.1 earlier regarding its cheap training cost. But as a practical tool for you today, it is highly useful for its exceptionally strong foundational search capabilities. It is a fantastic alternative for deep web research.
A really solid option.
Finally, for the developers out there, we have Printing Press. This is a command line interface factory that comes with over 30 pre-built agent-native tools. It allows you to instantly deploy AI agents into your development environment without having to build the complex pipelines from scratch.
When you look at tools like Kipera running your SEO autonomously,
Mhm.
or Codex in Chrome executing tasks across your browser, we are seeing a massive shift in your daily grind.
Your role is fundamentally changing.
Instead of being the person doing the tedious clicking, the endless searching, and the manual optimizing, your new job is to be the director.
You are now managing a team of digital agents that do the heavy lifting. Your value is no longer in the execution. It is in the strategy and the final review of the output.
The capabilities are expanding at a rate that is hard to fully comprehend, but the real power comes from learning how to direct those capabilities.
That brings us to the end of today's deep dive. Whether it is a software system navigating the extreme heat of the Neptunian desert to find hidden planets, or a team of sub-agents piecing together decades-old math proofs from rejected scratch pads, the underlying truth is the same.
The ceiling of human knowledge is suddenly moving a lot faster.
It is. But I want to leave you with a final thought to mull over. We talked about that Oxford mathematician who found a brilliant proof buried inside the AI's rejected, failed output.
The diamond in the rough.
If artificial intelligence is already hiding brilliant solutions inside its own mistakes, well, what happens when the systems get smart enough to start hiding their actual paradigm-shifting discoveries inside those mistakes on purpose? Just something to think about until next time. Be sure to follow and share the podcast.
Thank you so much for tuning in and exploring these incredible advancements with us today.
See you in the next episode.